Hello and welcome to Health Tech Happy Hour, Code Pour. I'm your host, Sean Van Sel. This is our very first episode, and I am super excited to get started. We were trying to figure out what the first topic was going to be, and we felt like no better place to start would be when rubber meets road, and that's really at the hardware-software integration stage. And so, we believe that in order to be successful in this space in software development, it's essential that you get that working seamlessly. And in this episode, we're going to talk about how do you improve integration. How can software engineers ensure that the product is not only functional, but is also safe and intuitive for medical professionals who rely on these products every day? And to help us with these questions, I brought in my first guest. I'm super excited and thrilled to introduce you to Tom Amlich. Tom Amlich is a solutions architect and a seasoned veteran here at MedAcuity. He's also my co-lead on the robotics practice. He is the brains to my beauty. I want you to hear from his perspective some of the things that he's seen in his career, maybe some tips and tricks to helping you guys improve. Maybe there's some valuable insights that you'd like to learn more about. So throughout this podcast, if there's things that you are excited about, comment in the section below. Let us know your thoughts. So before any longer here, I'd like to introduce you to Tom. Tom, take it away.
Yes, hello everyone. I'm Tom Amlich. I've been here at MedAcuity for 8 years now as a solutions architect, and then recently I'm now director of technology for our robotics practice. So glad to be here, glad to help kick off this new podcast.
This whole podcast started from all these conversations that we were having with our prospect clients, with our current clients, realizing there's just a lot of common trends that are happening. And really, I wanted to bring you in because of your architectural experience, but your experience from a systems engineering perspective, I think, is hugely valuable in the robotics space. And so this is where I'm going to start asking a little bit of a loaded question. What are some of the biggest challenges that you see when considering kind of the challenges around integrating software and hardware? And we'll use medical robotics as that reference.
Sure, Sean. I believe the big issue that I see over and over again is a lack of true understanding of the user needs and the system requirements that the team needs to follow to build a system. I think it's way too easy for teams to go off. For example, the controls team can very quickly get the robot up and running, and a surgeon can sit there and move the robot with the surgeon's console. But I think what ends up happening is the rest of the system pieces that are crucial for the entire system to get through FDA are lacking because of the requirements that pull everything together aren't there. And what happens is you grow a team sometimes very quickly, and you get a bunch of islands out there of people working towards their idea of what the system is going to be without a consistent one place to look to ensure that you're actually following in the same direction. You're not all in alignment. So we get called into a lot of projects to help readjust or maybe even step back and reset to get the project back on track.
To that point, though, what are some of the biggest challenges or what are some of the biggest things that you might see rear their heads later in the program when you haven't clearly addressed the issue of requirements and use cases properly?
Yeah, so what ends up happening is, once again, that controls team has that robot working great. Now, all of a sudden, you actually have some software that actually starts up the system and has the system follow through a workflow that it all has to work together. Maybe you're using a more secure communication system, but all the optimization that you got from that one controls team now has to all work together. And we find that once you turn on everything, all of a sudden the system doesn't have the performance it needs to pass all the messages around. Mm-hmm. And so everything comes to a grinding halt. You used to have surgeons come in and do a cadaver study and everything works great, and now they come in and it's a roll of the dice whether the robot's even going to work. I think a lot of that it could be avoided if you really had a good set of system requirements and user needs and a clear vision with strong leadership to ensure that goes out throughout the whole organization.
Yeah, I think it's the age-old challenge of hurry up and go, right? What we see this commonly happening with is when clients get funding, right? And then the clock starts ticking, right? And so it may not have been to the point where they've hardened all those requirements. And so they're super focused on just ramping teams up and going and hitting their schedules that they're not long before you realize you're deviating from the fact that you really haven't hardened those requirements. I guess our lesson here is spend the time making sure you have the requirements done.
Yeah.
And again, if you look at medical robotics as a general, they have very common footprints, right? So there is a surgical robotics system that has a patient cart, a physician cart, and most often there's a vision cart or something else in there. So let's talk about some important requirements in those systems. We hear a lot about like latency and other things. Let's talk about some of those important requirements to set as maybe being fundamental to your product.
Yeah, so having latency budgets, performance budgets, ensuring having checkpoints in your development process to ensure that you're taking into account all these budgets across the system, just straight up systems engineering where you actually figure out based on your communications bandwidth how much you can actually pass across the interface. And actually that derate that to maybe 80% or even 50% so that you have room to grow or add things in the future. Having worked in the DoD industry, that we always, in systems engineering, we always worked that way. We always made sure that all the systems we built had breathing space to grow over time, extensibility, and room to grow performance.
How do you factor that into the whole planning and requirement stage, though?
So what you end up doing is you specify what kind of performance you want, and then you have to, what they call derating, bring that back to the value that you're going to allow your teams to use, and actually budget it out based on processors that you have. And we have people that, I'm going to use DDS and I'm going to send messages everywhere. You can't really do that. You have to pick and choose what has to go, where has to go, and when. You can't just send everything everywhere because you'll just bring the system down to its knees.
Yeah, it's very easy to overload the system. This is before you start to bring in the concept of teleoperations, which will burden the system even more, right?
Exactly. Then you have some real challenges of finding latency over links that might be only 100 megabits or so.
Yeah.
And maybe unreliable or drop out periodically. How do you guarantee the system remains safe through all those contingencies?
We've worked on several projects that are introducing teleoperations into our system here. We won't get into any specifics here around what our customers are doing, of course, but yeah, what's the starting point on introducing a large new feature like that, which fundamentally changes the way that you use a product to an existing system?
Yeah, I think the first thing is to determine what can possibly be done based on the state of the art and have a good understanding of what that is. It's very easy to just assume that things are going to just work out of the box, but in the case, especially when we're dealing with medical systems where safety is of utmost importance, you can't just assume you're going to have the full bandwidth to use for your passing your video and your controls commands. You have to guarantee that any kind of mechanism that promotes safety is prioritized over everything else. And yeah, when you get into telecommunications, there's latency, and then ensuring that if anything happens, that the system always goes into a safe state and doesn't have any kind of negative impact on the patient or the people around the patient.
One thing that we probably come across most is the challenge of software getting ahead of hardware and there being hardware limitations. Can you talk about how you plan for that or how do you overcome it?
That's an extremely common problem anytime you're dealing with robotics, which is usually very expensive equipment that you only have so many instances of it. I had a chance to visit a friend at Boston Dynamics, and one of the comments he said to me was, this is the first place I've worked at that I actually have more hardware than I know what to do with, because we were all used to there's one robot, right, or there's two or three, and QA gets it for most of the time, and you have to sign up to get your time slot on it. That's just a reality that we have to deal with. And that doesn't even take into account the fact that if hardware is late, how do you just not stop what you're doing and wait for hardware? You have to keep moving. You have a bunch of requirements, software requirements that you have to implement. You need to come up with good ways to create simulators and emulators to test your software in a simulator and get it as good as you can get it without the physical hardware.
Can we talk about the simulators a little bit? What aspects of a system are we commonly using simulators? And are our customers accounting for building a simulator in advance?
I think good disciplined teams have experience with this, and so they know to set up a simulation or a good test environment so they can, even just good unit tests. You test your code as you go and don't wait till the end. We've definitely encountered companies or systems where they were too busy to unit test, and that doesn't always go as well as one might think it might. Today, especially with robotics, there are great open source simulators out there, such as Gazebo, and you can use those to simulate a medical robot or a mobile robot if you're dealing with mobile robotics. And so there are tools out there that you can test things out. You may need to put extra work into it to create something that's going to meet all your needs. One of the things that we do a lot of, especially when we're dealing with simulating low-level communications, is we'll actually create CAN, SPI, or I2C interfaces on PCs that we can then talk to from our development board. Mm-hmm. So we just simulate that's a battery management system on CAN, so we can send messages back and forth, and so we typically will have someone actually implement that interface in Python, and so it will receive and send the messages as if it was a battery management system on a battery, per se. Same thing for motor controllers. It all depends what you need to simulate and what level of fidelity you need to test your requirements.
Yeah, for sure. What role does real-time data processing play in ensuring a seamless hardware-software integration?
One of the things that you should definitely invest in upfront on any system is coming up with a good set of logging capabilities and ability to look at that data that you logged, or even find the data that you logged. We're creating gigabytes or terabytes or petabytes of data. Just saving it isn't any good. So we've spent a lot of time finding good tools to look at data. A good tool that we've used on projects is Foxglove, mm-hmm. which provides many different ways of pulling the data in and then displaying it as extremely configurable. You can customize it to exactly what you're trying to see. We've had great experience with using that tool. And there's other tools out there. Just the free RViz with ROS is great too. And there's more tools out there. Python, there's all sorts of things out there for Python. And then if you're a MathWorks shop, there's nice tools with the MathWorks, MATLAB, and Simulink that you can use.
In terms of some of the innovations that we're supporting, I feel like error handling and redundancy is a common pain point. Are there any suggestions you have for improving that reliability for the safety of the medical robot?
Yeah, absolutely. And once again, this ties back to your requirements. Many systems I've worked on, it wasn't until the end that you start thinking about the things that can go wrong. And so typically you end up, if you have the opportunity up front to create even when you're doing your risk assessment, to break that down into things that can go wrong and actually create requirements up front to address those things, you'll be much better off, especially when you're dealing with user interfaces and the user design, UX design, because if you have a good handle on what all the errors that can happen in your system, then you don't have to guess what these errors are when you're dealing with the UX people to figure out how they're going to get displayed as alerts or to notify the user.
There's a huge emergence of AI and machine learning and being central to the diagnostics aspect of medical robotics, right? Mm-hmm. Where do you feel like AI, ML aspect is going to impact hardware and software integration?
I think AI is definitely, in the last year or two, has hit just about every level of engineering. Mm-hmm. There's no tool that you can pick up or use on your PC that doesn't have some kind of AI extension to it now. So there are all sorts of things. We do a lot with RTI, DDS. They actually created their own...
Shout out to our partners.
Yeah, they created their own chatbot that they've trained it with all their documentation and training materials. It's pretty handy when you're trying to remember what that one QoS thing was. But yeah, there's some great things in there. We have clients that are using machine learning and AI for medical image data to identify problems as you're going through some kind of procedure. With the surgical robotics, I know many of the systems that we've worked on, they're collecting all the data. So as a surgeon is doing all the hand movements that they make or movements of the scope, all that data is getting collected so that someday they might have enough data to look at what common things occur that lead to good outcomes of surgical practices. And I wouldn't be surprised in the next couple of years if you see maybe as a surgeon some way that it provides some extra feedback based on learned past movements, whether from that surgeon or other surgeries.
Let's talk a little bit about test invalidation. What are some strategies that you would deploy to help improve that?
Hopefully, when you're doing your final verification and test, you actually have the final target hardware that you're testing. Otherwise, you can always test, but then you haven't verified on the final hardware. And I'm sure we've all encountered that situation. What you want to do when you're dealing with test and verification, and what I find very useful when we're using Agile and Scrum, is that the QEs are actually working along with the team and they're creating the tests as we go through the functionality. What's nice about that is that the tests are created at the same time the developers are creating the functionality, so everything's fresh in people's minds. And so if the quality engineers interact with the developers, you're going to get better tests and you're going to get better functionality, because that communication trade-off is the QEs will identify things before they become problems later on, so maybe even impact the design up front.
When it comes to the people who are helping at the integration of that hardware software, describe a profile of person that would be your dream pick to be part of your team.
I think the person that does the best in that situation is the one that's not afraid to roll up their sleeves and solve problems. I think it really just comes down to problem solving. So people that love puzzles and not afraid to roll up their sleeves and get their hands dirty do great in that field. The people that I don't touch anything from my keyboard, they're not going to do well. And we see people in robotics that may have never worked in the robotics area before, but finding out that it's more hands-on, it could be more fulfilling for them as a career because it's more hands-on. You get to see physically what your code is doing. I think we find a lot of people gravitate towards it. A lot of it's experience working with mechanical systems and understanding how things work. Yeah.
So really a systems engineering.
Yeah, I think so. I think it's really, and those are the people that I think do the best in robotics are the ones that are interested in the mechanical engineering, the electrical engineering, the software, a little bit of all.
So I'm going to ask you another question that is just broadly speaking. If there's one thing you want our viewers to take away from the conversation today.
Yeah, I think it's the whole system view, holistic view of the robotic system or medical device or whatever you're working on is really important. And then I guess passion for problem solving. And the robotic space, as we mentioned before, it's not just software. You're actually dealing with mechanical things and electrical things. So the people that excel in that are not afraid to go into those different areas. But ultimately, I think getting back to the software and hardware integration issues, having some really good technical leadership with a good set of requirements and user needs that everyone can look at one place as opposed to all over the place can really help create teams that can focus on getting their job done as opposed to reworking things over and over again because what someone told them wasn't really what the right thing to do was. I always strive up front to try to get as much of the requirements in shape before developers even show up so that it's all there, and then they find all sorts of things wrong with it that we can deal with, fix, and even make the design better. So,
yep. So look, this is our first podcast episode. Feel free to like and subscribe and comment if anything stood out today. Again, we're riffing off of this. We're just talking about what's top of mind, right? But there's so much that we could talk about. If you haven't seen our podcast with our partners RTI on the topic of teleoperations, I'll include a link in the comment section below. So thanks again for tuning in today to our very first episode of the podcast. It's been long awaited and looking forward to the next episode.
Thanks, everyone.